So welcome once again to a short video in Embedded Systems 2. And in this short video I'm going to look at the hardware connections or the interfacing of an analog to digital converter and 8 LEDs to the PIC16F84 microcontroller. So this is basically the connections you would need to make maybe on breadboard or maybe through printed circuit board to get an analog to digital converter and 8 LEDs connected to a PIC microcontroller. Let's have a look inside the PIC microcontroller. We can see it's a PIC16F84 microcontroller, and we know inside in this PIC microcontroller we've got 2 ports. We've got port A, and here's the port A register. We've got the tris A register, which is associated with the port A register. So port A has 2 registers, tris A and port A. We've also got port B, and port B also has 2 registers, the tris B register and the port B register. Now I've talked about how we have to set up port B almost always as an output port, and there's no change here. You can see the port B, and here's the port B register, is internally wired to pins 6, 7, 8, 9, 10, 11, 12 and 13 of the PIC microcontroller, and they're the port B lines. And they are wired to 330 ohm resistors to 8 LEDs, and the LEDs are connected to ground, of course. So if I send logic 1s and logic 0s into the port B register, they'll come out on pins 6, 7, 8, 9, 10, 11, 12 and 13, and these LEDs, D0, D1, D2, D3, D4, D5, D6 and D7, will turn on and off depending on the logic level in the individual port B register. So if there was a logic 1 here, this LED over here would be on, D0 would be on, and there's a logic 0 in the port B0 location, then this LED will be off. So a 0 or 1 in any of these positions here, or any of these slots here, will turn the individual LEDs on and off. Now I need to load a tris B register with 8 zeros, with 0, 0, 0, 0, 0, 0, 0, 0, or if you prefer 0, 0 hexadecimal, or just the number 0 and decimal. That tris B register has to have 8 zeros in it for port B to work as an output port. Now, I want also to connect the analog to digital converter. Now, I've only got 2 choices. I can connect the analog to digital converter to either port A or port B, but you can see port B is already connected here to 8 LEDs. That leaves me with only one choice. I must connect my analog to digital converter to port A. Now in this particular arrangement, I'm connecting it to port A lines PA0, PA1 and PA2. That's pins 17, 18 and 1. So those 3 lines there are connected to pins 6, 7 and 5 of the analog to digital converter. So my analog to digital converter communicates with the PIC microcontroller over those 3 port lines, and the port A lines, PA0, PA1 and PA2. So in this particular case, I'm not going to use PA3, PA4, PA5, PA6 and PA7. I've just crossed them out or put an X or don't care inside in those locations, inside in the port A register. They're unused, they're not used in this application. I'm only using 1, 2, 3 of the port A lines. I could use these 2 lines for something else if I wished, but in this simple application I'm not. To get the port A register to work properly, I need to load the following 8-bit value into the tris A register, 0000, 0001, and that's hexadecimal 01, or it's the number 1 if you like. Okay, so the tris A register has to be loaded with that value. Now I'll explain why the tris B register and why the tris A register have to be loaded with these individual values in another video. But basically that's the setup. So what I've got is I've got port A connected to 8 LEDs, and that's a pretty standard type of thing to do. And port B connected to 8 LEDs, I should say, and that's a standard way of doing that. And port A, 3 of the port A lines are connected to this analog to digital converter. Now, the analog to digital converter is an 8-pin device, so we need to connect all the other pins up to something as well. So pin 8 is 5 volts, so I need to wire pin 8 to 5 volts. Pins 3 and 4 need to be connected to ground. Pin 4 is the ground pin, and pin 3 is the reference minus pin, which always is connected to ground as well. So now we've got pin 6, 7 and 5 wired to the PIC microcontroller, pin 8 wired to 5 volts, pin 4 wired to ground. I want to set up a reference voltage here, and I'm going to use a variable resistor to do that. So I've got a 10k variable resistor here, and I'm going to set that reference plus voltage pin 1 to about 2.55 volts. And again in another video I'll explain why that is. The last pin is the analog input pin, which again I've wired to this 10k variable resistor, and that will allow me to vary the voltage on the analog input pin, and as that voltage varies it will be read in here, converted to a digital value, and then displayed on these LEDs. So that's the hardware arrangement for interfacing an analog to digital converter and 8 LEDs, and we'll probably be running some lab experiments on that in lab. Okay folks, that's the end of this video. Thanks for watching.